Hello, so we continue and Dr. Friedman's Physics 1 class with our study in Chapter 8 of different momentum conservation conditions and their consequences. Let's look at this problem number 824. A block A in this figure has mass 1 kg, block B has mass 3 kg. The blocks are forced together, compressing a spring S between them. Then the system is released from rest on a frictionless level surface. The spring, which has negligible mass, is not fastened to either block, and drops to the surface after it had expanded. So here you can picture that block B acquires this speed here given. And so we have V of B as 1.1. And we want to know, given this, what is the final speed of block A? This equals what? Where their initial speeds are 0. So we have conservation of what here? Momentum. There are no external forces acting in the horizontal direction, so that the horizontal momentum is conserved. The initial horizontal momentum, P initial for the system, is 0. The final horizontal momentum, one's moving to the left, one's moving to the right, but we have this and we want to solve this then for VA. So just algebra here. And we can put in the numbers, only one. And what is that? 3.3 meters per second. For part A. For part B, we are asked how much potential energy was stored in the compressed spring here. Here, not only is the momentum of the system conserved, but its energy also. And so let's use conservation of energy. But why, anyway, is energy conserved? Energy is conserved because there are no non-conservative forces, internal or external, doing work on the system. And though the spring force does work, it's conservative. So for part B, we have that the energy initial equals the energy final. What is the initial energy? The mechanical energy is kinetic plus potential energies. Here, initially there's no kinetic energy. So U initial, and that will be all the energy stored in the spring, so say 0 plus that, right? And for the final energy, there's no more energy in the spring. Finally, the energy is purely kinetic. So K final plus 0. And what does that give us? We're looking for U initial. So let's just write out what it is. It equals to K final And we have, it seems, all of these. Yes. Now that we have the velocity of ma, we could do a little algebra. Maybe tidy things up a little bit. Half a meter VB square times 1 plus MB over MA. And that looks like, what? 3/2 times 1.1 squared times 1 plus 3. Yes. So that would be 6 times 1.1 square, which looks like about 7.26 joules. That's the amount of energy initially stored in the spring. Should get it. There.